Good evening, and welcome to tonight's distinguished lecture, sponsored by the Global Policy Research Institute and by the Center for Education and Research in Information Assurance and Security. Very often when trying to introduce someone of distinction, what the introducer may do is pull out a biography and run through a list of accomplishments and awards. And that would take far too long for our speaker this evening. He has accomplished so many things. And that also fails really to capture some of the essence of what he's done. So I thought instead I'd reflect a little bit on introducing him in regards to the mission of a land-grant university, what we have here at Purdue, and the area of discovery, education, and engagement. Mr. Norm Augustine graduated with degrees in engineering and began his career at Douglas Aircraft Company, where he eventually rose to the position of chief engineer, a practicing engineer, work in scholarship. He's gone on to be involved in research and discovery in a number of different areas, leading efforts, including the Advanced R&D Division for the Department of the Army, and as chairman of the National Academy of Engineering. He's also served for several presidents leading commissions to study things such as the future of spaceflight. Distinguished career as a scholar. As an educator, he has also achieved distinction, not only heading such things as the National Academies. He's written several books, several articles. He's very well known for some of his advocacy of better education. He was here speaking earlier today to the College of Engineering about some of their advancements, and he's very well known as heading the groups that wrote the Rising Above the Gathering Storm reports. He'll be talking some, I believe, about education this evening as well. But to really understand some of the distinction and the reason that he is so beloved is how much he has contributed back to the community as a leader and as a volunteer, very selfless with his time. He has served in several volunteer capacities that I have already mentioned, but also distinctively chairman for 9 years of the American Red Cross, serving as president of the Boy Scouts of America, serving on the board of directors of Colonial Williamsburg, and a number of other things to contribute back to the community, more than simply following a career and following the work he's done in engineering. All of those things have contributed greatly to society, and in the process, he's visited 111 countries and both the North and South Pole. I don't know where he finds the time and energy, but we are very pleased that he was able to reserve some of that and his time to visit with us here tonight. Please join me in welcoming Mr. Norman Augustine.
Well, thank you, Spaff. That was a heck of an introduction for an unemployed aerospace worker. As you spoke, it reminded me of my first day of serving on the faculty at Princeton. Up until that time, I'd spent my entire career either in government or in industry, and I was asked to give the welcoming lecture to the incoming freshman engineers. And, the dean was making his own introductory remarks. I wasn't paying much attention to what he was saying, and I was flipping through my lecture notes, and all of a sudden I heard him say, and now we will hear from Professor Augustine. And this is absolutely true. For just an instant, the thought went through my mind, geez, what a coincidence. They've got some guy here by the same name as me. And I felt a little bit that way. On the other hand, to make things fair, I think that when I received an honorary degree from my alma mater, of course, I was very proud. The New York Times carried a story about the event. The headline to the New York Times piece read, Muhammad Ali and 3 others received Princeton degrees. So sometimes you can't win. But I will say at the graduation ceremony, when I did receive the honorary degree, they gave the honorary degrees out before they gave out the earned degrees. And so I went home and told my grandchildren that I'd graduated first in my class. I do appreciate having been invited to speak here today, and I've had so many friends at your institution, friends on the faculty, several presidents of your institution, a number of the students and former students, and among those was a friend who we sadly lost last year, of course, Neil Armstrong. And Neil, I think in my mind, stood out not only for what he did, but for how he did it and how he handled it. Truly a model citizen for your institution. Turning to my topic today about the growing problems and challenges and opportunities that face engineering and science in the years ahead. You know, as one takes an inventory of the challenges facing the nation, it seems likely to me that two fields, science and engineering, are going to have a disproportionate impact in solving these problems. And I think that's true whether you talk about rebuilding the economy and providing jobs, sustaining the natural environment, providing clean, affordable energy, providing national security, homeland security. You go down the list, healthcare. Science and engineering are really at the root of many of the answers to these daunting problems. But to solve these challenges is indeed going to be very demanding. And I will say what I'm about to say respectfully, but it's not likely to be the bankers or the lawyers or the politicians that find the answers to those questions. Unfortunately, scientists and engineers do have a record of producing answers to difficult problems. In fact, that's what they're all about, is solving problems. And on the other hand, I think one has to recognize that science and engineering also has produced its negative impacts. For example, I think of the 250,000 people around the planet who die every year in automobile accidents, or the hazards of nuclear weapons in terrorist hands, something I think is worth worrying about. And I also think that as engineers and scientists, particularly in the biosciences, work in the future, they're going to face enormous ethical questions that I would hope our universities will be able to prepare them to deal with. But the enormous positive impacts on science and engineering on our lives, I think, inarguably have been on the positive side in the balance. One is also struck, as one looks at the past, at the enormous pace of change of science and engineering. It seems to be accelerating. The more we know, the more we discover there is to know. If I might use a personal example, my mother, who lived to be 105, she was born in Colorado in 1893. And Colorado was more or less the Wild West in those days. And that was 10 years before the Wright brothers flew. It was 36 years before, and I should say the Wright brothers flew a whole distance of 120 feet. And it was 36 years before Dr. Robert Goddard hit his aunt's cabbage patch in Massachusetts, launched his liquid-propelled rocket to the astounding height of 41 feet. And the New York Times at the time gratuitously said that he had fallen just 240,000 miles short of the moon. Nothing has changed. But my own mother had friends who had crossed the prairie in covered wagons, and she had met friends of mine who've been to the moon. That's in one lifetime. And I would suspect that as a youth, she never even imagined things like Earth satellites, GPS, polio vaccines, smallpox vaccines, genomic analysis, cell phones. You could make this long list of impacts that scientists and engineers have had, even things like electric dishwashers, which would have been one of the great breakthroughs. I think one has to conclude that we're not very good at predicting where science and engineering is going to take us. Certainly not 50 years from now, probably not even 20 years from now. But we do know that historically we have overestimated the near-term impact of scientific breakthroughs and generally underestimated their long-term impact. And I would cite the laser as an example of the latter. And as an example of the former, my favorite is a statement by a gentleman, Alex Lewitt, who in the 1950s ran a home appliance company that bore his name. And at that time, he made the following statement, and I quote, "Nuclear-powered vacuum cleaners will be a reality within a decade." The impact of science and engineering achievements, though, has certainly not been limited to hardware. It's impacted the political sphere and many others. And one thinks back, the Soviet Union wasn't able to keep out with its wall, have its wall keep out the radio, the TV, the videos that really had a major effect in changing the Soviet Union, bringing down the wall. Who would have thought just a few years ago that an argument between a street vendor in Tunis and a policeman would prove to be the fuse that would set off the overthrow of governments throughout that part of the world. And the impact of modern communications has really have changed all of our lives rather fundamentally. And if you'll permit me a moment for a brief digression to cite a rather trivial example of this emerging power of modern technology. It's trivial, but it was one that I personally observed not too long ago. With the encouragement of their parents, my grandchildren and 3 grandchildren of a friend of theirs were encouraged to, or the parents encouraged them to set up a lemonade stand and earn a little bit of money and give it to charity, which they did. Put a sign out in front of the lemonade stand that the money would be given to Children with Cancer, the research organization. And in a very superb example of being at the wrong place at the right time, I showed up to buy a lemonade at precisely the same time as the county inspector showed up to confiscate the lemonade and point out that the children had no license to sell lemonade in our county. The end result was that since I was the only one around with an ID, I wound up with a citation for $500 and a mandatory court appearance. Now, what that has to do with my remarks today is that a passerby happened to have a cell phone and recorded part of the incident and put it on YouTube. And it went viral all around the world. It was unbelievable. The reaction against our county government was overwhelming and instant. And the thing that broke the camel's back, they told me, was when a TV program in Iran called the State Department because the TV program in Iran was using this as an example of what life is like in America. And the bottom line was that my $500 fine was waived and that this never would have happened with that outcome. Even a dozen years ago, I would have been out $500. But just somebody with a cell phone was able to change the outcome. And I've seen playbacks from TV all around the world covering this. A totally new world that we live in. And that's a modest example. You might ask, what's the greatest example of the impact of science and engineering in the same general area? That is, my candidate would be globalization. And I refer to jet aircraft that make it possible to move objects, including people, at nearly the speed of sound, at relatively low cost around the world. And I refer to modern information systems that let you move ideas, knowledge, thoughts, data around the world, literally at the speed of light. And Francis Cairncross was writing in The Economist and said that distance is dead. And that to me is those are 3 of the more profound words I've heard. Distance is dead today. It was killed by modern science and technology. And in fact, Arthur Compton, the Nobel laureate, wrote in 1927, "The communication by printed and spoken word and television will be much more common, so that the whole earth will be one great neighborhood." But I think to fully appreciate just what's happened, I like to use an analogy that I will share with you, or a little story. And to do that, I would ask that we turn the clock back turn it back about 200 million years, or a little more than that. And my geologist friends tell me that at that time, there was a supercontinent that we now know as Gondwanaland. It consisted, of course, of Australia and Africa, South America, the Indian Peninsula, the Antarctica, and Saudi Arabia, and a few other places. And about that time, it began to break up, and the pieces, of course, spread out across the planet. And as they spread out, the geologists point out that they had less and less impact on each other. Well, then my economist friends tell me that just a couple of decades ago, all these pieces suddenly came smashing back together again to create the global world that we live in today. And the astonishing thing, of course, is that you have something that took hundreds of millions of years to move apart. Suddenly, it's all back together again. In the global village, change occurs very fast. And I think this is going to be particularly true in academia in the next decade. And I always like the quote from Alice and Lewis and Carroll's Through the Looking Glass, actually the Red Queen, that had said that here you see it takes all the running you can do to stay in the same place. If you want to go somewhere else, you must run at least twice as fast as that. And indeed, that's the world that we live in. And let me cite an example of a fairly simple product in this globalized world. And, let me use the electric toothbrush as an example. The CEO of Bausch & Lomb was talking about their product, and he was saying that their toothbrush's electromechanical design was performed in Germany and Japan. Its motors were from China. The brush head was from Ohio. The batteries from Japan. The molded plastics from Georgia, the state. The charging base was from Hong Kong, and the final assembly was in Mexico. And the sales were all around the world. Certainly one of the more fundamental impacts then of globalization has been that workers and companies no longer compete with their neighbors around the same town or city as it used to be. They now compete with workers all around the world for jobs, and companies compete for customers. And in terms of the workers, more and more of those people all around the world that they have to compete with are highly motivated and increasingly well educated. There are a lot of examples of this death of distance in our personal lives that we've already seen. Let me share just a few to make the point. I recently called a customer service department from my cabin that we have. It's at 9,000 feet altitude up in the Colorado Rockies because my TV quit working, my satellite TV. And it turned out to get my TV fixed up there, I had to speak with men and women, first in Denver, then in Jamaica, Indonesia, the Philippines, and India. But between them, they managed to get my TV working without anybody showing up at my doorstep. And I'm told that in India, to better prepare young people to fill jobs in call centers, that they're taught to speak, they give courses on speaking with a Midwestern accent. And a true story was I'm told that they were also encouraged to take on a Western name to make Americans who call into some of the call centers more comfortable. And I have a friend in Maryland who talked to a fellow in India not too long ago, and the fellow in India swore his name was Abraham Lincoln. That's the world we live in. If you visit a firm that has an office right by the White House in Washington, D.C., the receptionist there doesn't sit at a desk in the lobby. She's on a flat screen display. She handles your appointments and anything that needs to be done. But she doesn't live in Washington, D.C. She lives in Pakistan. And the CT scans that patients get at many hospitals in this country are read by physicians in real time or near real time in Australia and India. And as we all know, pilots located in Nevada fly aircraft to attack targets in Afghanistan. And the greatest example I've run across yet is a patient in Strasbourg, France, who had his gallbladder removed by a surgeon in New York using a remotely controlled robot. And as an engineer, I hope they had a backup surgeon somewhere in the room. Now, in this New World Order, it seems likely that maybe the more established, more developed countries that are going to be the most challenged. One reason for that is that one can hire 9 unskilled factory workers in Mexico for the cost of 1 here. I visited a plant in Vietnam where you could hire 20 assembly workers for the cost of 1 here. You can hire as many as 5 chemists in China for 1 here, and so on. Now, the productivity rates do differ from country to country, but not enough to make that kind of difference in wage scales. And over time, wages elsewhere will rise, undoubtedly, which will be good, but it will take a long time for that increase to bring wages into equilibrium. There are also many other challenges that American business will face, and I'll touch on some in a few moments, but the effects of globalization are obviously very real. And just since the year 2000, about a third of all U.S. manufacturing jobs have disappeared. That's about 5.5 million jobs, incidentally, and about 42,000 companies in manufacturing have disappeared in this country. And it's a full-service problem, though. It's not simply people working in manufacturing on assembly lines that are impacted. More and more work could be moved abroad because of the death of distance, and it's impacting everyone from accountants to dentists to radiologists to architects, professors, scientists, engineers, even basketball and baseball players. And in addition to factories that had been moving abroad, more and more it's prototype shops, administrative offices, laboratories that are being moved abroad. And it is or should be widely recognized among our nation's leaders that the people having a job is really the basis of the standard of living, but it's also the basis of the tax revenue that government receives to provide us with the things we've come to expect from our government, ranging all the way from health care to Social Security, from education to physical security. But it would seem that we may be entering a period of chronic, sustained unemployment because of certain structural flaws in America's economy. And the future real unemployment rate, underline real, is very well likely to be closer to today's than it is to the historical rate that we often cite. And concerned about this situation, a few years ago, members of both political parties in both the House and the Senate asked the National Academies of Science, Engineering, and Medicine to create a committee to answer the question, what should America do to be more competitive, i.e. for jobs, in the decades ahead? And in search of an answer, the academies set up a group of 20 people. I had the privilege of chairing that, and the group included presidents of public and private universities. It included CEOs of corporations. It included former presidential appointees. There were 3 Nobel laureates, and it included the head of the state public school system. And I note with pride that upon completion of our work, 2 of our members joined the President's cabinet. One is Secretary of Energy and the other is Secretary of Defense. And the committee became known as the Gathering Storm Report because we used that as a title, the first line of the title of the report that we issued. And the conclusion, unanimous, of that group was that really the only leveraged avenue for America to compete in the emerging market, global market, would be through one word, namely innovation. And by innovation, we meant creating new knowledge through leading-edge research and applying that knowledge to produce products and services through world-class engineering, and then taking those products and services to be first to market through world-class entrepreneurship. And if you reflect upon that conclusion, one realizes the enormous importance of our universities in making America competitive. Since they are going to be, I would suspect, and I'll make the argument in a moment, a primary source of new knowledge and is virtually the only source for knowledge requiring higher education, or for individuals, employees requiring a higher education. The Academy's conclusion was, to a considerable degree, influenced by a series of studies that one of which won a Nobel Prize, incidentally, that have demonstrated that over the last half century, roughly, that 50 to 85% of the growth of the U.S. GDP can be attributed to advancements in either science or in engineering. It's also been shown that about 2/3 of the growth during that period of time in productivity is attributable to advancements in science and engineering. My own analysis indicates that for every percent in the last half century that the GDP has grown, you get about 0.6% growth in employment or of jobs. And one could certainly argue the cause and effect, the relative magnitudes of cause and effect here. I think the overall impact and connection is evident. And to those who would ask what business an engineer has doing economic analyses, I would merely remind you that I really am a rocket scientist. The academies summarized their findings in the following words: the United States must compete by optimizing its knowledge-based resources, particularly in science and technology. Now, still another report a few years earlier than that, that was prepared by the Hart-Rudman Commission, named for Gary Hart and Warren Rudman, the two senators. They were co-chairs, and I was a member. That commission not only warned well before 9/11 that Americans were likely to die, in our words, by the tens of thousands on U.S. soil due to the actions of terrorists. The second conclusion that we offered, and I will quote it, was second only to a weapon of mass destruction detonating on an American city. We can think of nothing more dangerous than a failure to manage properly science, technology, and education for the common good. That was a very bipartisan group and a unanimous finding. Now, while the Gathering Storm Commission did emphasize the importance of science and engineering, it did not focus per se on jobs for science and engineers. One of the reasons is that science and engineers are less than 5% of the workforce. And expanding that even by a large percent doesn't impact the overall workforce that greatly. But the point is that the work performed by that 5% grossly disproportionately impacts the creation of jobs for the other 95%. And for example, you take the iPad, the iPod, the iPhone, BlackBerry, and so on. They're all rooted in much earlier work that was done in solid-state physics and quantum mechanics. They created jobs not only for scientists and engineers and factory workers and truck drivers, salespeople, and even musicians. And a study that was reported in the Journal of International Commerce and Economics pointed out that just a couple of years ago, the 700 engineers who were working then on Apple's iPod were accompanied by 14,000 other workers in the United States and nearly 25,000 abroad. That's the multiplier effect to which I refer. Floyd Kvamme, who was a highly successful entrepreneur, has said, and I quote, "Venture capital is the search for good engineers." In fact, Steve Jobs told the President of the United States that the reason Apple employs 700,000 workers outside of the U.S. is that they couldn't find 30,000 engineers in the U.S. Most recently, Microsoft is setting up a software engineering facility just across the U.S. border in Vancouver because our immigration policies deter it from hiring a sufficient number of qualified engineers from around the world. Other nations have not overlooked this circumstance. Take China, where as many as 7 of its 8 top leaders at one time have been engineers. The premier of the State Council of the People's Republic of China had to say the following: "The history of modernization is in essence a history of scientific and technological progress. Scientific discovery and technological innovations have brought about new civilizations, modern industries, and the rise and fall of nations. I firmly believe that science is the ultimate revolution." End of the quote. And arguably the greatest advantage that the U.S. enjoys today in terms of competing in the global marketplace, the greatest advantage other than our democracy and our free enterprise system would have to be our great research universities. And according to the Times of London, all 5 of the top 5 great universities in the world are in the U.S., and that 18 of the top 25 are located here. Shanghai's Jiao Tong University points out that of the 500 top universities in the world, and I should say this is based mainly on research contribution, points out that the U.S. has 8 of the top 10 and 17 of the top 20 universities by their measure. But one of the things that's becoming more and more apparent is that we're living off of our past investments. And at the time we did the Gathering Storm report, I don't recall anybody raising the issue that our universities could be endangered in terms of their position in the world. But Suddenly and really quite, I think, unexpectedly in all quarters, today it would seem that our great universities truly are endangered. And I think there are several causes of this. One is state tax revenues have declined. State net support to universities have also declined, in many cases precipitously. Also, as a result of this, our universities in many cases have found their huge budget shortfalls and had to take draconian corrective measures. Probably the most prominent of those is the 83% tuition and fee increase that the state of California has imposed on its universities in a 4-year period. And during the most recent decade, our state research universities that educate 70% of our scientists and engineers that have on average seen a 24% reduction in their state support. And that you have to add to that, of course, the impact of inflation. And although there have been increases in need-based tuition support, it doesn't begin to offset those cuts. State support for students per capita is now at the lowest level it's been in 25 years. And in short, I think it's fair to say that many of our states have decided to disinvest in education, effectively privatizing their universities, but doing so without sufficient endowments and without removing some of the constraints the state has imposed on our universities. And I was at the University of Colorado last Friday. They get now 4% of their operating budget from the state, virtually a private university in many respects. And that's in spite of the fact that study after study has shown that education is the best investment an individual or a state can make. A state, because the increased wages of a graduate over their lifetime will produce additional tax money that even when discounted, more than pays back the state's investment in supporting that education to begin with. And it does seem rather starkly clear that if a developed nation is going to be able to create jobs for its citizens in an era of rapid globalization, that we're going to need a truly world-class educational system. And that's particularly true in science and engineering. But today in the United States, only 16% of our baccalaureate degrees are awarded in those two fields. In China, incidentally, the share is 47%. In the specific case of engineering degrees, in China, at the baccalaureate level or first degree level, 21% of the degrees are in engineering. In Europe, it's 12%. In the US, it's 4.5%. And most of these measures, a couple of decades ago, the US would have ranked first. I think it's also worthy to note how quickly a nation can lose its leadership position in science and engineering. And to that end, Craig Barrett, who ran Intel, he was CEO of Intel and was a member of the Gathering Storm Committee, told us that of the revenues that Intel receives on the last day of any calendar year, 90% of them are derived from products that didn't even exist on the first day of that same year. That's how quickly business is moving in the high-tech area. There was also a recent NSF study that looked at 93 different nations from the standpoint of the fraction of their first degrees that go to the fields of science and engineering. In the field of engineering, the United States finished in 79th place out of 93rd, suggesting the emphasis that we as a nation are placing in the field. Incidentally, I think that says something about differential tuition that's a topic in its own right. The country that most closely matches us in that regard is Mozambique, in both science and in engineering. And the only countries that fall behind us, and if you will, their disinterest in engineering, are the following: Bangladesh, Brunei, Burundi, Cambodia, Cameroon, Cuba, Zambia, Guyana, Lesotho, Luxembourg, Madagascar, Namibia, Saudi Arabia, and Swaziland. That's where the U.S. is falling today in terms of their emphasis in science and engineering among first-degree recipients. Recently, there was a full-page article that appeared in the Washington Post that the headline read, "How to Get Good Grades in College." And the subhead read, "Don't Study Engineering." Not terribly helpful. And exacerbating the dilemma that we face is this enormous leakage in the talent pipeline. And I went through and did a little calculation that if in the year 2029 you want to have one more PhD in this country in engineering, you have to start with a pool of 3,000 students in 8th grade to produce that one PhD in engineering. A strong case can probably be made that America's science and engineering enterprise would hardly function today if it weren't for the immigrants to this country who've chosen to stay and contribute here. And that's the way we've made up for the lack of interest among native-born citizens. Immigrants make up about 12% of the U.S. workforce, but 52% of the PhD holders in science and engineering in the hard sciences and under the age of 45 are foreign-born. Immigrants started about 1/4 of all successful high-tech companies in recent years, and about 18% of the Fortune 500 companies are led, or should be, were founded by immigrants. And if you include the children of immigrants, that figure rises to 40% of the Fortune 500 companies. I received an email a while back from George Heilmeyer, who George was head of the Defense Advanced Research Projects Agency, later CEO of Lucent. And in his email to me, it was from Moscow, George said that when he was in Russia, he always likes to go to the movies. And he went on to explain, because in Russia, the engineer always gets the girl. Actually, I should tell you, I met my wife when I was in engineering school. We've now been happily married 51 years, but she now tells me that the odds were good, but the goods were odd. But engineers take pride in that. But that brings us to another, perhaps far more important problem, and that is that in America, all too seldom is the engineer a woman. And women today, of course, comprise over half the population. They comprise 58% of college graduates. They're 72% of the valedictorians in high schools now. But in engineering, they're 20% of the bachelor's population, 19% of the PhD population. And if one looks at, I might say too, they amount to 48% of both medical school degrees and law school degrees today. Members of minority groups today are underrepresented even more. African Americans and Hispanics each represent about 12% of the population. They receive fewer than 5% of the degrees in engineering at both the bachelor's and the doctorate level. There have been a few encouraging signs recently, but it's early to draw conclusions. And if a nation lets well over half of its population not be involved in what may be the driving fields in the years ahead, that nation is going to be very disadvantaged in competing for jobs in the global marketplace. So what is critical, I believe, is for America to produce a cadre of engineers who are risk takers, entrepreneurs, Imagineers, as Jack Welch says, people who can see around corners, because these are the people who really do produce most of the jobs for others. And it also points to the importance of continuing education for these people if they're going to be productive throughout their lives, because both engineering and science are fields where without continuing education, continually learning, one can be professionally middle-aged by the time they're 30 years old. Let me turn then to the subject of research, which is the source of the building blocks that engineers apply. It's certainly one of the major roles of our universities. The total federal investment in the fields of mathematics, engineering, and physical sciences today is about equal to the cost increase in this nation in healthcare every 10 weeks. In the case of U.S. patents, the number of grantees has now been passed by foreign grantees. These are U.S. patents. That occurred in 2008. After ranking for decades as first in the publication impact of U.S. research articles, we're now in third place. And as a nation, we spend about half as much on energy research as we spend on potato chips. One could argue that investing in research should be the province of corporate America, because corporate America is certainly a major beneficiary of the results. But in a recent survey where chief financial officers of large corporations were asked a question, they 80% of them answered to that question that they would be willing to forego research and engineering within their company in order to meet the next quarter's profit projection. That's the short-term nature of business today. Constructive or not, it's a reality. It used to be 2.5 decades ago that the average shareholder held stock 8 years. Today they hold it about 4 months. In the company I used to work, they held it 18 months. So your shareholders have no interest in the long term or in research. All of which is to say that I think our nation's future is going to depend more and more on our universities for educated people and to perform research. And who's going to pay for that research? The only real avenue I see is the federal government. There are others that will contribute, but if we're to have a real impact, I think the federal government is going to have to step up to this. Sadly, the great institutions like Bell Labs and Xerox PARC and IBM's research lab, GE, Schenectady, and others have, I believe, seen their best days. Margaret Thatcher summarized the significance of basic research in the following words, which I've always liked. She said that although basic science can have colossal economic rewards, they're totally unpredictable, and therefore the rewards cannot be judged by the immediate results. Nevertheless, the value of Faraday's work today must be higher than the capitalization of all shares on the stock exchange. The greatest economic benefits of scientific research have always resulted from advances in fundamental knowledge rather than search for specific applications. Transistors were not discovered by the entertainment industry, but by people working on wave mechanics, solid-state physics. Nuclear energy was not discovered by oil companies with large budgets seeking alternative forms of energy, but by scientists like Einstein and Rutherford. But bring about the change that will be needed in our universities to live in this new world with the pressures that are being applied is going to be a significant challenge. And one of the things that will add to that challenge, other than budgetary problems and tuition levels beginning to have to level out, more competition from abroad, will be the impact of technology on pedagogy. That I think we're just seeing the leading edge of what could happen. And that'll be a huge change. If you think back for a century, the principal elements, if I may, of education have been a professor and a student and a book, and a blackboard and a piece of chalk. And I had a professor at Princeton, a very respected gentleman, who once said that the objective of higher education was to transfer knowledge from the professor's notebook to the student's notebook without it going through the student's head. Hopefully that's not the case. But all this traditional approach to education, so ingrained, is about to change due to the advent of open courseware, computer tutors, MOOCs, and all the other developments. And the signature of a great university has always been a fine library and a great faculty. Today, the students can carry the library in their pocket and hear lectures from faculty around the world without charge. Incidentally, I made that comment about libraries in an article I recently wrote, an editorial for Science Magazine, and I think I heard from every librarian in America. Fortunately, they're a fairly peaceful lot, I think. As I've been thinking about the university of the future, I've tried to think kind of a worst case or an extreme case, if you will. I think it's instructive to think about the unthinkable. And one of the things that triggered me to do this, I was talking with a newspaper publisher not long ago, also published one of the great news magazines, and he was talking about the publishing business. And his comment to me, and I'm going to quote, "We are all dead. Some of us just don't know it yet." And I think of my own industry, the aerospace industry. When the Berlin Wall fell, within 6 years, we lost 40% of all the employees in the entire industry, and 3/4 of the companies disappeared. That's in 6 years. So change sometimes really does happen, and it happens fast. Well, what might this change look like at our great universities? Let me offer one possibility. That it's not a possibility I would particularly endorse, but it's one that's plausible. And it could happen, I think, in a decade or two. First of all, for economic reasons, the universities will operate at full capacity 12 months a year. Students will be divided into 6 groups, each group of which will be on campus for 2 months every year, during which time they'll do their laboratory work, meet with their professors, and meet with their fellow students. All lectures will be held online. They can be watched, they're world-class professors, watched 24 hours a day for the students' convenient. Some of the professors will probably not even still be living. The classwork will be taught entirely by adaptive computers, tutor computers. The computer itself will grade all papers, exams, including in the liberal arts. The faculty will devote most of its attention to performing research, writing papers, publishing the results. Tenure will disappear due to the pressures of the marketplace, and the departments will disappear from the pressure of transdisciplinary developments or advancements. And for the students who don't want to engage in the 2 months a year campus experience, there will be legitimate profit-making corporations that will crop up. They will offer independent tests based on the free online courses placed by the finest universities in the world, and will hand out certificates for a very low fee based upon one's passing the bona fide tests. The certificates will eventually be collected. The degrees will be awarded from these universities, so-called universities, and those certificates will eventually be recognized as generally comparable to a degree from our traditional universities. The students taking the examinations will pick and choose their courses from universities around the world, sort of in an academic smorgasbord. Oh yes, I forgot to mention the library. The library will be converted to a gymnasium where unionized student athletes will play for pay. They will move from school to school depending on the compensation package that's offered, just as their coaches do today. Pretty awful? Many would say it is. The good news is it'll make higher education of some quality level available to almost everyone. It'll be affordable. The bad news, it'll almost certainly divide our society more into 2 groups. The one group that will get its education sitting in its apartment looking at a computer, the other group that will have a campus-based experience. It should be noted, though, that I think there's an alternative, and that is a more modest impact of our application of technology and pedagogy that I think could actually improve the quality of education, certainly reduce its cost, but maintain many of the advantages of the traditional university campus environment. I noted that during the recent political campaign, it was the habit of many candidates to blame China for America's competitiveness problems. And certainly China is no paragon of virtue in this regard. But we do need to ask, is it China that runs our public schools? Or does China decide how many of us will study science and engineering? Does China decide how much we should invest in research? Does it limit the number of talented scientists and engineers that we allow to remain within our borders? Some months ago, I was testifying before a Senate committee asking for greater financial support for science and for higher education, for all education, particularly higher education. And one of the members apparently had grown frustrated with me and interrupted and said, "Mr. Augustine, don't you realize that this nation faces a budget dilemma?" He said, "You're always over here asking for more money for science and for education." And probably more succinctly than wise, I answered by saying that, yes, I do understand that this country faces a budget problem, but that I'm an aeronautical engineer. During my career, I've worked on many airplanes that during their development programs were too heavy to get off the ground. And never once did we solve the problem by taking off an engine. Well, the audience burst out laughing. The senator didn't appreciate it very much. But I think it made the point that the engine that does drive our nation, the engines are science, engineering, education, and entrepreneurialism, I should add. And I might say that I was flattered that President Obama used that same analogy during his next State of the Union address. So in concluding, let me just note I'm often asked whether I'm an optimist or a pessimist. I usually answer by quoting the old sage that says that a pessimist is a person who wants to be an optimist but has the knowledge of the facts. I prefer, though, to say that, as you no heard Winston Churchill famously said that you can always count on the Americans to do the right thing after they've tried everything else. This is one we need to get right this next time. So thank you very much for your attention. It's been a pleasure being here. I understand we do have time for a few questions, I think, and I'm told that there are microphones out here in the audience that we should use. This is being taped, apparently. And if there are questions, I'd sure be happy to try to address them. So if someone has one, wants to hold up a hand, we'll find where the microphones are. Right, let's see, do we?
Norm, do you see, where's the middle ground between the university model that's existed for hundreds of years and the Brave New World model that you went through? What is a more, maybe probable view that you see coming along?
Yeah, great question. My suspicion will be that it will be a model where lectures do more or less disappear, and that more and more emphasis the lectures will disappear because of distance learning, with world-class faculty teaching courses all around the world. That universities will continue to operate 9 months a year with an on-campus experience. The classes will take on a different character, that much of the preparatory work will be done with computer tutors, but that the classroom discussion will be smaller classes and more dealing with the issues that an individual student faces rather than what their friends face. And that the library will probably disappear. I think the athletic programs at major colleges are going to go through a major change. I suspect that's true. We have in the last 4 years, 3 of the 4 years in inflated dollars, faculty salaries on average in this country have declined. And the 4th year they broke even. But we have 62 head football coaches who make $1 million or more a year, up to $6 million. And one conference now is paying $27 million to coaches not to coach because they've been fired. And so that part of the world I think is really going to change. And don't mark me as anti-athletics. I'm not. My son-in-law played in the NBA and so on, played at Duke, and so I'm very pro-athletics, but I'm not pro the way they're done in universities today. I think we've lost our priorities. So I think we'll see a lot more use of distance learning in our universities, but certainly not to the extreme level I've described. I hope that's the case. Did somebody else want to?
So you've talked a lot about higher education and getting more scientists and engineers through that end of the spectrum. But really, the interest in science and engineering starts much, much earlier. I wanted to be an aeronautical engineer when I was 8, when I was 9, in elementary school. So what do you think we can do to encourage or develop the interest in elementary school and middle school when kids are figuring out what they want to do later on in life, and get them started thinking about being an engineer or being a scientist earlier, and keeping that motivation going through middle school and high school up to lead into.
Terrific. And could I ask you what caused you to be interested in aeronautical engineering at that age?
Part of it was my grandfather was an aerospace engineer at Boeing, and he sent me a model of the space shuttle. And so in building that model, I wanted to learn more about it and what it looked like and everything, and so that kicked it off.
Well, that's terrific. I frankly was just the opposite. When I was my junior year in high school, a teacher called me and asked me what I wanted to do. And I said, I grew up in Colorado, loved to camp and hike, and so I said I wanted to be a forest ranger. And he said, that's not what you're going to do, and he handed me 2 envelopes. I had never met an engineer, I don't think. I really don't. I was thinking that the other day. Until I went to college, I don't remember meeting an engineer. So everybody has their own formula. And he gave me 2 envelopes, said one was an application to Williams and one was to Princeton. He said, go fill those out. And I said, well, even if I could get in there, I couldn't afford to pay. And he said, if you get in, they'll pay you to get through. Next thing I know, I'm at Princeton, and they want to know what I want to study, and I said forestry, which they thought, well, yeah, you got it. They thought that was the funniest thing they'd ever heard. And so that's what I wanted to study. I'm getting off your question a little bit, but show that everybody has their own pattern in life. And I said, well, if you don't have forestry, what do you have that's like it? And whoever I talked to said geological engineering. So I said, okay, I'll take that. And I studied it for a year, and then through another set of circumstances, switched to aeronautical engineering, which I loved. And I think there are different points in people's lives when they make these decisions. Mine was very late, yours was very early. But the more I've spent time studying K through 12 education, I used to think that it was at 8th grade that was the pivotal point. Because at 8th grade, if you don't take advanced algebra, you sort of deny yourself the option, it's only an option, to be an engineer because the hierarchical nature of mathematics education. The more I've learned, I think it's around 4th grade where we lose most of the scientists and engineers. For the women, the young girl, their father says girls don't study math. The most common thing, though, is that in our public schools, the chance of having a teacher in math or science who has a degree in math or science are minimal. And so students don't get inspired, and students ask, why is this important? And the teacher doesn't know. And so I think the one most important thing we can do of all is to be sure that every student in K through 12, make it 6 through 12, has a math and science teacher with a degree in the core subject, math and science. And we don't even come close to that today. I think the next thing is to do things that inspire people and expose them to it, just like your model of the shuttle. In my age group, if there's an audience like this, I would ask how many of you decided to go into math or science or something related to engineering because of the space program? Half the hands would go up. And I had the very good fortune, the week I started graduate school was when Sputnik went up. And that was when there was a huge increase in spending and research, a big increase in higher education and engineering. And it made all the difference in the world. So I think we need some things like that that will excite young people. There are things going on. First Robotics you're probably familiar with. There are others. The National Math and Science Initiative that will help hold that interest. But today we lose about 1/3 of our kids that don't graduate from high school. We lose another almost half that don't go to college. And in engineering, we lose almost half that start out in engineering. And once they get their degree in engineering, we lose about half to Wall Street or someplace. So there's huge leakage in the process. Great question. Any others, please?
You've arrived in a state where the legislature felt that the problem with higher education, one of the problems was that it was just too darn hard, and so they talked about limiting it to 120 credit hours to get your bachelor's degree, which to me sounds like a company, like you noted, cutting their research budget when they're losing money. I know you talk about engineering requiring a degree, even more work past a bachelor's degree. Can you talk a little bit, an engineer in the field working may help contribute to 7 other jobs or 20 other people behind, working with them. Can you talk a little bit about how an engineer that works in policy, that works in education, that works in communicating to legislators, doing those sorts of things, can start changing society, can start changing ideas? So talk about your thoughts on the outside, in educational study, bachelor's degree, not just the science and technology, but the other liberal arts and other activities.
To build support for that?
Sure, just in general, how an engineer is helped by that kind of broad knowledge as well.
If I'm reading your question right, it's to build support for science and engineering and studying the field. I think, a couple avenues. One's the grassroots level. Get involved in things like FIRST, and that's the robotics program that Dean Kamen started. And I think individual engineers and scientists can have a huge impact that way. The other thing I found is that if everybody goes and sees their local congressman, it does make a difference. And I can't tell you the number of hours I've spent beating the halls of Congress, but you can eventually make an impact. You just have to keep telling the story over and over. And I first started doing this, let me say one of the lessons I learned, if you can get somebody to go with you who doesn't have a dog in the fight, so to speak, you have much more credibility. And I first got into this 25 years ago. There's a fellow by the name of Bert Richter, who was a Nobel laureate. And Bert and I used to beat the halls of Congress and the White House and talking about the importance of science and engineering and research. And Bert was virtually retired at that time. I was CEO of an aerospace company, so I didn't have a dog in the fight in terms of K through 12 education particularly, or higher education, only in a very, very long-term broad sense. And I found that if we went into these offices, one thing, people would let us in because they couldn't figure out what a Democrat and a Republican and a Nobel laureate and a CEO would have in common that we would talk about. People would tend to listen. They'd say, yes, it's strange these people agree about this. Maybe it is worth thinking about. So if you can encourage people like somebody from the local business community and somebody from the academic world to go together to see senators and congressmen and state legislators and governors, I think you could make a difference. I'm absolutely convinced of it. And in fact, that's the way we got the America Competes Act passed twice, and I think we're about to get it passed a third time. And I see the hook there, so let me thank you all for your hospitality. I enjoyed being here.
Let our guests leave with a gift from
Oh, how-
Purdue. So this is from the Global Policy Research Institute.
If we had 3 or 4 sponsors, we'd have to get you a backpack, but
Okay, thank you so much. I
Thank
appreciate
you.
it, Pat. Thank you. Thank you.
Thank you so much.
Thank you all. Good luck.
as a note, we have recorded this lecture, and after it's prepared, it will be available as a recording through the GPR website and through the Sirius website. We encourage you to encourage your friends, your colleagues, to tune in and see that for those who weren't able to come tonight. Thank you again for being here, and we'll see you again in another lecture soon.